Hey guys, I'm Quads. I'm about to start my sophomore year of college. And I'm here with Memphis Communiversity to do the worksheet on relative max and mins. You can find the worksheet and the answers in the description of the video. So to kind of just talk about what those are, we're just taking this like nice curve here. You can ignore the circles for a second. Here's our function. It's got so many curves. The relative maximums are like if you're taking like a part of this function, like the highest point of that part. So it's not the highest point of the whole function, but you're just like looking at one region and like where's the highest point. And so you can see on this picture, here's a highest point, here's a highest point, here's a highest point. It's also where it changes direction and goes from increasing to decreasing, which we'll talk about in a minute. And then, of course, the relative minimums are the same right here, right here, right here. If you're familiar with absolute maximums and minimums, and if you're not, you should check out the video because I made it. Then the cool thing is, so like the absolute maximum minimum is just like the biggest, highest point of the entire graph, lowest point of the entire curve. Those are also Rellmans and maxes because like if you're just looking at this region, see like this is the highest point of the whole curve. But if we're just looking at this region, where's like the local highest point, it's still right there. So an absolute max is also a rel max. And absolute min is also a Rellman. So there's our little picture overview. I'm going to talk about the ways we actually find them. The most common one you're going to use is the first derivative test. So I'm writing that out and then I'm going to kind of like talk through what that means. Basically, what you're going to be doing is taking the derivative and then making a sign chart. So you're going to take the derivative, factor it as much as possible, and then use those zeros to make a sign chart. And then from there, we'll be able to tell where the mins and maxes are, and this is why. You'll be able to see it once I move my hand for a split second. So here we have the like written, we have the rule written out in words. So like f has a rel max when f prime goes from positive to negative. And f has a rel min when f prime goes from negative to positive. And basically what that is like, I'm going to draw it here. If f prime is going from positive to negative, that means f is going from increasing to decreasing. If you remember, like f is increasing where f prime is positive. So if f is going from increasing to decreasing, then you have, you can kind of see it for a second. You have this curve and that's like got a highest point right there. It's changing direction, so there has to be a highest point. And the opposite is true for rel mins. It's going from negative to positive. F prime is going from negative to positive, which means f is going from decreasing to increasing. So it's important to note that when we draw our sign charts, we're not going to be looking for the highest point on the sign chart. We're looking for where, because it's going to be a sign chart of f prime. So we're looking for where f prime goes from positive to negative or negative to positive. So it's going to be where it crosses the line, the number line. So it's not going to look like a maximum or a minimum. It's going to look like a critical point because it is a critical point of f prime. But for f, that's like it is a maximum or a minimum. So we also have something called the second derivative test. You're not going to use this near as much, but it should also be called the first and second derivative test because you have to use both. So your first step is going to be to take the first derivative and set it equal to 0 and get your zeros. And then you're going to take the second derivative and you're going to find out if it's negative or positive. Because basically what this test says is you have a rel min when f prime of x is 0 and if double prime of x is greater than 0 is positive. And that's because when f prime of x is 0, we have a horizontal tangent line, which like if you're going to have a highest point or a lowest point, like if you have this like curve, the like tangent line at that highest point is going to be horizontal. And so the derivative is 0, but then the second derivative, if you remember from shapes of curves, is going to tell us the concavity at that point. And so it's going to tell us if we're concave up or concave down, which is really important because if you have a local min, like if the curve is concave up, then it looks like this. I'm going to see, I'll draw it in a second. Maybe I won't. It's going to be like a U shape, and the bottom point is going to be your local min there. Yeah, here we go. We got this horizontal tangent line and this concave up shape. And then we have our rel min. And then if our second derivative is negative, then here's our horizontal tangent line and it's concave down, which means we have a relative maximum. So it's kind of contrary to what you think, because you would think when f double prime is positive, you'd have a max, and negative, you'd have a min. That's not true. Positive is a min because it's concave up, and negative is a max because it's concave down. Also, sorry, I just like really couldn't use my words to describe the curve and the concavity. You guys are probably like, quad, so it's not that hard. But here we go. Finally figured it out. Also, it is, I forgot to write this, but under what circumstances is it inconclusive? That's in a super rare case when f double prime of x is equal to 0. Because then, like, yeah, you wouldn't be able to use the test to tell. Probably like 80% of the time, you're going to be using the first derivative test. We're going to be doing those sign charts for the first derivative. The only times like you're not doing that is like, well, on this worksheet, it's going to explicitly tell you use the second derivative test. But like in real life, in your real calculus life, if you can't make a sign chart for the first derivative, because there are like some cases where you can't draw one, that's when you find those critical points and then you take the second derivative and then you find out if it's negative or positive at those points. So you're not going to make a sign chart for the second derivative. I'm going to talk about it more when we get down there, but you're just finding the zeros and then you're going to plug them in to the second derivative, and like at that point, yeah, is it negative or positive? So we'll get there, but for the first derivative test, yeah, you're going to be taking the derivative and then drawing a sign chart for the first derivative, but you do not draw a sign chart for the second derivative. And that will just be like more clear when we actually get there, but yeah. Okay, so we are going to go ahead and get started on the actual things. So remember, first step is take the derivative, and then we're going to factor as much as possible. I've dubbed the term AMAP instead of ASAP, like as soon as possible. We're factoring AMAP. Hope you like it. So here we go. We have like this little power rule, 6x squared minus 6x minus 12. We're going to pull out that 6. And then we can factor that into x minus 2, x plus 1. And so if you don't remember how to do sign charts, then like you should watch the sign chart video that Japu did. It's really awesome because it will be kind of hard to follow this worksheet if you don't know how to do sign charts, and you like won't be able to do the test if you don't know how to do sign charts. So go check that out, or if you need a refresher, I'm gonna explain them as I go, but like a brief version. I'm not gonna be like teaching sign charts, so just for clarification. Also, I'm so sorry you can't like see my work right now, but this is an even and positive final like factored thing. We have like 2 x's or x squared, so it's even and it's positive, which means we got, my hand's in the way still. Both sides are positive on the ends. It's a little upside down parabola here, or right side up parabola. I always get that mixed up, my bad. And then we are going to look for we're looking for where it changes positive to negative, negative to positive. So rel max, I'm going to move my face up, is when it goes from positive, because it's increasing, to negative. So that's here, positive to negative, and that occurs at -1. And I just kind of like wrote the brief explanation. Because remember, this is f prime. So this point right here does not look like a maximum, but it is because it's like positive. So f is increasing to negative, f is decreasing. And you'll be able to see my words in a moment when I realize that my video is not working and move it or off the page. But the realm min occurs at x equals 2 because it's going from negative, so it's decreasing, and then it goes to positive. So it's then increasing. And that is a realm min. So there we go. Number 4, get some fun factoring on this one. Take our derivative. F prime of x equals 3 times, and bring down that 3 from the power rule, x squared minus 2 squared, and then we got our chain rule times 2x. And that is 6x, just multiplying these, times x squared minus 2, all quantity squared. I'm going to move my face again. And then 6x, and then we can factor this part into x. We're going to do a difference of squares here. X minus root 2, x plus root 2, and then the whole thing is still squared. And then finally, we're going to distribute like that square. So 6x times x minus root 2 squared times x plus root 2 squared. So now we can draw our sign chart. This one is even, or odd and positive. I'm sorry, that's 5 x's, x to the 5th. And so we are going to have it ending in positive, but it's going to start negative. Our zeros here are negative 2, negative root 2, 0, and root 2. We're starting negative. It bounces because this isn't even power, and then it goes through 0 because it's an odd power, and then it bounces again because it's another even power. That's what our sign chart looks like. And so now we're going to locate our mins and maxes, and remember, for it to be a min or a max, it's like going increasing to decreasing or decreasing to increasing. F is going increasing, decreasing, or decreasing, increasing, which means f prime is just changing positive to negative or negative to positive. So these spots here, or at 0, it's a min because it's going negative, so it's f is decreasing, and then f prime becomes positive, so f is increasing. But these other two spots, it bounces because we have our even power. And so it's neither a minimum or a maximum because there's not like a direction change in f. It's just a continuation. The sign doesn't change. So you can write neither. That is a valid answer and a correct answer. So you don't want to do that. For number 5, start with our derivative. This one's a product rule. So we have 1 times e to the negative 2x squared plus x times, and then the derivative of this, so we get our chain rule here to get negative 4x. And then we are going to keep this e to the negative 2x squared and then multiply this here. So we have 4x squared times e to the negative 2x squared minus. And then we can factor out the e to the negative 2x squared. And we're just going to go ahead and like factor out a negative e to the negative 2x squared. We'll pull out the negative sign. And then we're left with, oh man, my hand is in the way. I'm so sorry, guys. I'm ruining this video. I'll pause it here and go back through what I did. Ignore the x right now. And then we have 4x squared minus 1. We just did 2 steps into 1. We pulled out the e to the negative 2x squared. And then it was 1 minus 4x squared. And so pulled out a negative and switched that. So you can see this negative. We didn't X that out. That's important because that affects the sign chart. It tells us it's negative. This e to the negative 2x squared we don't need because it's always positive. E to the anything is going to be positive. Even if it's to the negative something, it's still positive, which means it's not going to change our sign chart because anything multiplied by something positive keeps its sign. So it's not going to change a sign, so we don't really need to worry about it, so we just X it out. But you have to be careful not to X out the negative, because that negative matters, because it shows us the whole sign chart is negative. So do a little work getting the zeros for this guy, and we end up with x is plus or minus 1/2. Write out those steps. And we know that because it's even and negative, it's going to start negative and end negative. And it's going to go through in both spots because it doesn't bounce. It doesn't have the even power. So our REL max, remember, is when we're going f prime is positive to negative because f is increasing to decreasing. So positive to negative happens at 1/2. And our REL min is where we go from f prime goes from negative to positive because f goes from decreasing to increasing. Did I do that upside down with my mouse as I said? I'm sorry, guys. Forgive me if my words aren't matching my mouse. Trust my words. Yeah. So negative 1/2 is our REL min. Number 6, we have a nice little quotient rule. So we have our low times the derivative of the high, which is just 1. So remember low d high minus high d low over low low. That's our rule. If I move my hand, you can see it. Low d high minus high d low over low low. We're just going to factor that. That's x squared plus 4 minus, which multiply these together, 2x squared. Combine those x squared, so we have 4 minus x squared. And we're just going to switch that around. You have to keep moving. Pull out that negative, and we get x squared minus 4. And then, of course, we have a difference of squares. So we have a negative x minus 2 times x plus 2 over x squared plus 4 quantity squared. So we are just going to X out the entire denominator because, again, it has to be positive. Like x squared has to be positive because it's squared. We're adding 4, and then even then that whole thing is squared. So even if it was negative inside, which it couldn't be, it would still be positive. It won't affect our signs. We're Xing it out. So we have even x squared here, 2 x's, but it's negative. And our squares are 2 and negative 2. And it doesn't bounce because each of those are just x to the first, so that's odd. REL max, we have f prime going from positive to negative at 2. And REL min, we have f prime going from negative to positive at negative 2. Number 7. Got our product rule here. This is not too bad, but it's a little messier. So we have our x minus 2 times the derivative of the second one. So that's power rule, 2 times x minus 3. And then for a chain rule, like it would just end up being times 1. And then plus, so it's like this whole thing, plus x minus 3 squared times 1, because that's the derivative of that one. So we're going to pull out x minus 3 from both of those. This is just a back and forth, isn't it? And we get x minus 3 times 2x minus 4 here. I just went ahead and distributed that too. So we have 2x minus 4. Plus another x minus 3 left over because this was squared. And then this can be like 2x plus x is 3x minus 7 here. but I wrote plus by accident, but it's minus. So our zeros then are 3 and 7/3. And this is even and positive. So our rel max is where f prime goes from positive to negative. That happens at 7/3. And our rel min is where it goes from negative to positive. That happens at 3. And here's our just friendly little reminder of what f is doing when f prime goes from positive to negative, or negative to positive. Those are over the graphs of f, if that was unclear. Number 8, you have an ln rule. So remember, it's this whole thing on the bottom. So it's like 1 over that times, we have chain rule, the derivative of this inside stuff, which would be 4x minus 4. You can factor that, factor a map as much as possible. Pull out a 2x, here we go. So this one's odd and positive. We have our zeros of 1, 0, and 2. 0, 1, and 2 if you want to, like, do things in numerical order. Positive, so it ends in positive. It's odd, so it starts negative. And each of those x's are an odd power. They're all to the first, so they go through. So our rel max happens at x equals 1 because f prime goes from positive to negative. But we don't actually have any rel mins because 0 and 2 are not rel mins. They're critical points. They are critical points, like they're zeros and we need them to draw the sign chart, but they are in the denominator of the derivative. And so the derivative does not exist at those points, so it can't be a minimum or a maximum. Yeah, because like we're doing it to see like where where these would need to equal 0 to make the whole thing equal 0. But if something on the bottom equaled 0, then the whole thing would not exist. So there's not. I tried to draw an open circle at those points. They're not, the derivative does not exist there. So it's just a critical point. Because if you remember, the definition of critical points is where it equals 0, where f prime equals 0 or does not exist. We don't X those out like we did the things that are always positive because like they helped us draw the sign chart. We needed them. But yeah, just be careful. So I would just check those all. Like I went ahead and wrote the max first and then was like, oh, the other ones aren't mins. I would just like look if you have a fraction problem and go ahead and determine 0 and 2 are not mins or maxes. Okay, number 9. Ooh, we have trig here. So the derivative is sine x minus 1/2. And if you remember trig and the unit circle, the zeros of sine x minus 1/2 are pi over 6 and 5 pi over 6. That's where sine x equals 1/2. So on this sign chart, it's actually a sine, S-I-N, graph, because it's sine. So 0 and negative 2 are bounds, because like if you remember, I don't know why I wrote negative 2. That's supposed to be 2 pi, because of the interval. I'm so sorry. That doesn't make sense at all. 2 pi. 0 and 2 pi are the bounds. They're not zeros. Because if you remember, like sine just repeats itself over and over again. So that's the interval, and so they're the bounds. So here we have our sine graph, and it starts a little lower than the line because it's negative 1/2, so it's shifted down a bit. But the rel max, where f prime goes from positive to negative, is 5 pi over 6, and the rel min, where f prime goes from negative to positive, is pi over 6. Number 10, f prime of x We're just going to go ahead and factor it, take the derivative and factor, and then we'll get to this g of x, the strictly decreasing part. So that's g prime of x to the third minus 12x, and then we have chain rule. So we do times 3x squared minus 12. And that would be, pull out the 3. So we got 3g prime of x cubed minus 12x times x squared minus 4. And then we can break that down into difference of squares, x plus 2x minus 2. Here's the thing. You're like, what do we do with this function in the middle of it? We don't know what it is. Very true. We do actually know the sign, though, and that's what matters for the sign chart. This thing has to be negative because g of x is strictly decreasing. It is always decreasing, which means g prime of x is always negative. And again, my writing is cut off, but I'll show you eventually. So this little part from g to the end of this parentheses is a negative sign, basically. That's what we get from that, which is important because this one is even because we're looking at these two x's, and negative because of this big fat negative sign. And then our zeros are 2 and negative 2. You can't see it. Our realm x is at 2 because it goes from positive to negative. You'll be able to see it in like so soon. I'm so sorry. And our realm min is at negative 2 because f prime goes from negative to positive. This part of it just looks like every other one we've done. The weird thing about this one was the strictly decreasing part. So if you get something like this with a whole other function in there, you just take the derivative of it, move on, leave it there, and then realize, oh, that's a negative sign, basically. Okay, second derivative test time. This is it. Really the first and second derivative test, because the first thing we're going to do is take the first derivative and set it equal to 0 and get our critical points. So our first derivative is using that power rule, 4x to the third minus 16x. Factor that a map. We have 4x times x squared minus 4, and then I feel like we've done x squared minus 4 like so many times on this worksheet. X plus 2, x minus 2. So here's our first step. We're taking the zeros. Set that equal to 0. You know how to do this. Critical points are 0, 2, and negative 2. So now it's time to take the second derivative. And what you might be tempted to do is find the critical points and draw a sign chart, because that's what we've been doing. Like first derivative test, you take the critical points of the first derivative and draw a sign chart for the first derivative. Second derivative test, you do the same. Not true. We're going to take these critical points we found, because that's where there's a horizontal tangent line, because the derivative equals 0. And we're going to plug those in to this second derivative that we found, 12x minus 16. We're going to plug each one in, and we're going to see if at that point where the tangent line is horizontal, is it concave up or concave down? Because that's what's going to tell us if we have a maximum or minimum. We're not looking at the increasing, decreasing thing that we were before. So we're going to plug in negative 2 first, and I forgot the square here, but it's supposed to be squared, and that's supposed to be a positive 32. So f double prime of negative 2, 12 times negative 2 minus 16. 32 is positive. And remember, it's weird, you like think positive and you want realm x, but it's a realm min because this curve is concave up because it's positive, concave up, and so we have a realm minimum. Plug in 0, f double prime of 0, 12 times 0 minus 16 gives us negative 16, which is negative, and that means it's concave down. And we have a maximum, a relative maximum. And then finally we'll plug in 2. 12, f double prime of 2 is 12 times 2 minus 16. It also equals 32, which is once again positive, and it's the same thing as right up here. We have a realm min. And so our third step, I guess you can call it, is looking at the sign, the concavity, to see if it's a min or a max. And we're just going to do that one more time. First derivative, x squared minus 5x plus 6. Remember, you only need to use quotient rule if there's x's on the bottom. I was really bad at remembering that. We can simplify that to x minus 2, x minus 3, set it equal to 0, and our critical points are 2 and 3. And then we take the second derivative, so 2x minus 5. And remember, don't do a sign chart. We're plugging in these zeros into 2x minus 5. So f double prime of 2 is 4 minus 5, that's negative 1. It's negative, which means it's concave down, which means we have a relative maximum. And then f double prime of 3 is 2 times 3 minus 5. That gives us 1. Positive, concave up, which means we have a rel min. See that? And that's the worksheet. So, like I said before, if you don't know your absolute maximums and minimums, which are different process than this, because this is only telling us, like, where are the spots where there's a relative maximum or minimum, but, like, how do I know which one of those is the biggest? Find out by watching my video, yours truly. And yeah, that is it for this worksheet. I hope you found this video helpful. If you did, like and subscribe. We've got tons of other helpful videos. And hope you have a wonderful day. Also, if you have questions, you can leave them in the comments of the video. And there's also a Discord server that you can use. It's in the description of the video for other calculus questions you have that you need help with. Have a lovely day, people. Bye.